Hi, Professor Philippe Lambin is a radiation oncologist at Maastricht University and a researcher who has been very successful in obtaining large research grants over the past half year. How did he manage that? What role did his 7 children play in it? And does he have any tips for everyone who'd like to receive over 3 million euros of research funding in half a year? Let's find out in this Zoom interview. Professor Lambin, you told me earlier that you have recently discovered a new hobby, academic entrepreneurship or startups. Can you describe for us the path that has led you there?
I firstly became a medical doctor working for a period of time in Ivory Coast and Bolivia. Then I chose a technological specialty and became a radiation oncologist. I followed this with a PhD in molecular biology in Paris. And more recently, one of my professional hobbies is academic entrepreneurship, or startups if you prefer. After 15 years, I thought it was time for a change. And as I discover, I'm a better pioneer than a consolidator. This led me to create what should be the ideal research department. In a way, precision medicine is a live experiment with biologists, AI specialists, astrophysicists, lawyers, psychologists, mathematicians, bacteriologists, medical doctors, epidemiologists for more than 10 different countries under one roof. In a way, the hypothesis of our experiment is that diversity is a great force towards creativity. I don't know any other comparable situation. It is really an uncharted territory, really.
But how do you get all these diverse people to interact in a productive way?
Imagine you put a bacteriologist and a psychologist and a data scientist in a room for 2 hours and ask them to make a proposal for a disruptive research project. This is what we do every week.
That asks for liters of coffee and lots of guidance, I presume?
We do not give them too much guidance, they just need some direction. Sometimes they have very animated discussions, but essentially team spirit, and then the magic occurs.
Sounds great. So what's the overarching goal of your department?
Importantly, we are a disease agnostic department. What we want is to make the life of people with chronic disease better. To do so, we have 2 keywords: conversion science, as illustrated by our logo. All our projects fall within the intersection between the clinic, technology, and biology, the 3 petals of the flower of our logo. Until now, the experiment is successful, I would say. And I'm very, very grateful to the University of Maastricht and the Research Institute of GROW to have supported me.
Could you be a bit more specific on your research questions?
The first one is, how can we extract useful quantitative information from medical imaging like CT, MR? We do this in collaboration with radiology and nuclear medicine. The second one from the D Lab is, how can we build a multifactorial decision support system integrating all the information available, genetic, clinical, treatment, etc., to facilitate precision medicine or to choose the best treatment. And then we have 2 wet lab questions. How can we exploit the tumor microenvironment to cure cancer? And finally, how can we explore living medicine, namely sporulated bacteria, to prevent and cure chronic disease? We also want to focus on research that has an impact and cross the so-called 2 translational gap. The first one is from lab, wet lab or dry lab, to clinical trials. The second one, actually broader, is from scientific publication to routine care. So for each research question, we have a close connection with at least 1 or 2 companies to implement our findings in routine care.
So is your department already making a difference in daily healthcare?
Well, our department has the ambition to be a disease agnostic. So we are already applying our AI tools to diseases such as multiple sclerosis, cardiovascular disease, Alzheimer's, diabetes, viral disease, and others. And to give you an example, our living medicine, the bacteria Clostridium, can colonize tumors to deliver therapeutics within the tumors. You have a type of intratumoral factory working 24/7, but can also be taken orally to produce a vaccine against an infectious disease.
So let's talk a bit more about your research grants that you obtained this year, all 5 of them.
One is on totally new treatment that could in some cases replace radiotherapy. Nanoprobes activated by low energy X-rays irradiation produced by a CT. 2 are on AI for imaging, radiomics, a concept we co-invented in 2010. One is a technology transfer grant on automatic detection and segmentation of tumors, mainly lung tumors. And one is on coronavirus. But I'm also very proud that we have had 4 submitted patents this year. This is a sign that our research is groundbreaking and can have a societal impact. And by the way, I find that we should all learn more about writing patents. That should be encouraged a lot more because patents are one of the bridges between the academic world and societies.
Could you maybe tell us what's the secret of your success?
Good question. I'm convinced that having a clear vision towards multidisciplinary, groundbreaking research, second, an international network of people who you trust, and a brilliant team that support each other and work as a whole helps to get grants. That's what you need.
Okay, but can you maybe be a bit more specific with some tips, perhaps?
Okay, let me give 7 tips, but there are more, obviously. First, be reviewers of other grants. It costs time, but you will learn a lot. You learn, for example, that the weakness of a grant has more impact than its strengths. I build, for example, a list of rejection reasons of grant. It is very informative. Second, the project needs to fit 100% with the grant requirements. Then you need to build a good, motivated team, one internal, one external, people you trust and work as one team with the same goal. Then in your grant, you have to work on the why. Why are we writing this grant instead on focusing too much on what are we going to do? That's a classical mistake. Then you have to be transdisciplinary rather than monodisciplinary. And I would say involve companies. It's so much more attractive for the grant funding bodies when it's company involved because all our economies are based on SMEs. And then a few days before the submission, use a checklist and ensure that at least 5 people have read it, at least 5 times. That's what we call the 5x5 rules. And then lastly, be stubborn, very stubborn. The success rate of European grant is about 5%. So the quote, failure is not fatal, it is the courage to continue that counts, is very, very true for grants. For example, our first coronavirus grant was rejected, but the second one was so much better, a killer.
And what impact does the corona crisis have on your work? Does it make things more difficult?
Well, personally, I find it easier. I love working at home with a view on the garden, my 55 kilos dog next to my feet. There is also more asynchronous communication. The meetings are more focused, more efficient. And personally, I don't have to drive more than 2 hours per day. So in short, I feel I'm 200% more efficient.
So the effects of corona on your life and work are mostly positive?
Oh yes. First, we realized that we could be dead tomorrow, especially at my age. So it's an extra motivation to do something that is meaningful and impactful. Then we are living an economic, ecological and health crisis. People realize that what we need is a disruptive research, not a Me Too research. It also know that creativity loves crisis. One of the most creative solutions in human endeavor have come about of a crisis. So I really hope that mankind will learn its lesson and bounce back to a new normal.
And what do you think are the key elements in that new normal?
Yes, I believe that in the concept of new normal, that we should not just go back as it was before. So I have a few slightly provocative statements. I hope you will make you think. First one is that creativity loves a crisis. Then working at home should be encouraged, especially in the academic world. Then a more controversial monodisciplinary research is dead, or at least in a deep coma. And finally, all scientists should be trained to submit patents and pay for them with their own budget to be responsible.
Last but not least, you didn't really mention your own leadership qualities in this story, while I think it is quite crucial too. And I heard your 7 children have something to do with that.
That in many ways has provided me with the best ever leadership training. With 7 children, there is always a crisis to deal with, and you cannot fire anybody.
True words. Well, Professor Lambin, thank you very much for taking your time and for your inspiring words.
Okay, and thank you very much for listening to this interview. Have a good day and be safe.